All right, so in the last video, we set up this 3D environment. As you can see, the light is still not coming from positive Z, right? Our light is still coming from somewhere over here in the positive Y direction. And the reason for that is because while we set this up to look nice, it's not actually totally what we want. It's because ultimately our goal is to be working with 3D objects that we're going to be exporting from Blender and bringing into P5.js. So it's important that the object data is going to match our environment coordinate system. So what we're going to do is we're going to create objects in Blender, export them with the Z-axis up, and then we need to bring them into here, and we're going to be looking at the vertex information for the object. So like each coordinate system, each point of the vertex, the 3D coordinates, and it's going to be important that it matches. We don't want to have to do a lot of like fixing rotations and stuff. So to make it easier on ourselves, see, now this is looking good. Without this rotation in here, our light is coming from positive Z. So let's avoid this rotation. And we're also going to take off orbitControl. And we're going to try to sort of roll our own. So there's something called camera. Camera 300, 300, 300. So this will be the camera's position, is these three XYZ coordinates. And then the look at point, we want it to look at 0, 0, 0. And then the up vector, which we want to be 0, 0, 1, I think. Positive Z. Let's try this, see what we get. Interesting. Okay. For some reason, it wants the negative Z. All right. This is still good. Now we can see we've got the lighting coming from positive Z, which is what we want. And yeah, cool. So now if we wanted to do some rotation stuff like we had going with orbitControl, we can sort of write our own orbit camera, and sorry, that's going to bother me. Let's do something. If mouse is pressed, then we will say, let's start with something really basic. So something that's just super dumb to start. So let's say like counter equals 0, just a global variable. If mouse is pressed, counter plus equals 1, and then we'll do camera of this same exact thing, but we're going to add this variable that's going to be ever increasing when the mouse is held. Oh, we have to call orbit camera. Otherwise that code isn't going to run. Mouse is pressed. And we can console log to see what's going on. Pressed. F12 to open up the console. So we're calling this twice. That's the problem. So let's call this in setup. There we go. So this is getting that. The problem was this was getting called after orbit camera. So it was calling, it was basically setting the position, rotation of the camera and everything in orbit camera. And then I was having it right here, just overriding what I just set. All right, so that's fixed. Okay, so now we can sort of see how, you could get something going here with either the mouse or the arrow keys to get it so that things rotate around. And one way I've done in the past to handle this type of thing is create a camera object. So we'll call it cam, and we're going to give it position. Actually, that's kind of overkill. We don't, yeah, let's just do X. It'll just be a top level property. 300, Y 300, Z 300. And then we're also going to do something with rotation. So we're going to say, I forget what it's called, azimuth and something else. We'll call it theta and phi. So theta will be around the z-axis, and phi will be around the x. Start with 0 for now. And we'll also do a distance, which is going to be the other reason I like to use the math property is because if we did the square root outside of a P5 function like setup or draw, it's like not going to recognize it. So it's just good to get in the habit of using math dot, I think. All right, we're going to take the square root of 300 squared plus 300 squared plus 300 squared. Okay. Things are happening. So now let's say and I think this would be like pi divided by 4 to start. We're going to have to calculate this out. So we're either going to be going from camera coordinates to angles or from angles to camera coordinates. Camera coordinates being like x, y, and z. So you got to either think of that also like Cartesian to polar, where for polar we have rotation about the z, rotation about the x, and our radius, which is the distance that we want to move from our look at point. Speaking of a look at point, we should add that as a property as well. And we'll say look at x 0, y 0, z 0. Cool. All right. So now, in interest of clarity, I can say cam.x, cam.y, cam.z, and cam.lookat.x, cam.lookat.y, cam.lookat.z. And our up vector, for now, we're just going to have that. That'll always be the up vector. If we wanted to at some point mess around with that, we could add that, you know, as a property. But for now, I'm just going to leave it so that we always want the camera to be aligned properly so that Z is up. So let's just prove this works. Sweet. Now I want to rotate the camera, not based on a global counter variable, but based on how much the mouse has moved. So I will create a variable called mouse previous. And that'll be x and y. And then if mouse is pressed, we're going to say theta, sorry, cam.theta plus equals mouse x minus mouse previous dot x. And let's just try that first, and then we'll have to do something where we properly update things. So we're going to say cam dot, so we'll start with the easy one. Cam dot z is not going to change for this. We're just going to be rotating about our look at point. Cam dot x and y are going to change, and they're going to change by, so we're going to be projecting cam dot distance down to the xy plane. So to do that, we also want cam dot phi, which we know is 45 degrees. Did I say cam dot dist? Yeah. So cam dot x equals cam dot dist times cosine, math dot cosine of cam dot phi times math dot cosine of cam dot theta. And then cam dot y is going to be the same thing, except sine. Okay. Counter is not defined, right? So we're no longer doing this. We're doing this. So we've updated cam x, y, and z. Yeah, sweet. All right, so now we just need to make this much smaller. So we'll divide that by 100, the amount that we're changing theta each time. There we go. Oh, and I'm never updating mouse.previous x, so I have to make sure I do that, because right now it was always just 0. So mouse previous.x equals what mouse x is right now. All right, and now this number is way too small. But there we go. So we're on our way to making our own sort of orbit control. You can see we're snapping to a point. Why? Why is it doing that? Every time I click, it goes back to that point. I started at 0. Oh. Oh, it's because the mouse position. So as long as I click in exactly the same spot I was in, then we're good. But if I do a previous mouse position that's different than my last one, it'll rotate a lot. So how do we fix that? We could just say something like this. So I'm going to move this up here, and then every time at the end, I'm just going to update it. I think we don't need this anymore. Whoa. Oh, sorry. Yeah. So now I can move the mouse. And we're good. All right. The next video, we're going to talk about some more WebGL stuff. I don't know.